Hello! In this video, we are going to prove the following theorem. Suppose A, P, Q are integers such that P and Q are relatively prime, P divides A, and Q divides A. Then, P times Q divides A. And so, we're given that this is true. And the whole goal is to prove that this is true. Now to start the proof, since we're given P and Q are relatively prime, if we recall, this is equivalent to saying that there are integers s and t, such that ps plus qt is equal to 1. And next, since p divides a, this means that there exists an integer such that a is equal to p times that integer. I'll call that integer j. Also, since q divides a, this means that there exists an integer such that a is equal to q times that integer. I'll call that integer k. Now remember, our whole goal is to show that pq divides a, which means we want to find an integer which satisfies a equals pq times that integer. Now, at this point, we know that this is true, and this is true. And we can combine these three equations together to arrive at something of the form a equals pq times an integer. And to see how, if we take this equation and multiply a on both sides, we're going to get a equals aps plus aqt. And what we can do is we can substitute a here for qk and substitute the a here for pj. Because if we do that, we see that both terms have a pq in it, so we can factor out pq. Of course, since all four of these guys are integers, this entire thing is an integer. So as you can see, we have a equals pq times an integer. This tells us that pq divides a. And that is exactly what we wanted to prove, so this completes the proof. And so yeah, that's pretty much it for this video.